Now let us talk a concept called weightlessness. To discuss this concept again, consider a satellite rotating around the earth. Let us suppose this is the earth and इसके अराउंड एक सैटेलाइट रोटेट कर रहा है ऑफ ऑर्बिटल रेडियस small r. Let us suppose this is the satellite whose orbital radius is small r. Now you see, first of all, try to understand why the normal cracker rockets we throw, then the leftover object is not rotating like a satellite, but whenever we are throwing professional satellites with the help of a larger rocket, it is rotating. You understand? There might be this question in your mind that जो भी हम ये क्रैकर रॉकेट्स थ्रो करते हैं वो एक सैटेलाइट की तरह अर्थ के अराउंड क्यों नहीं घूमता, रादर इट जस्ट गोज अप एंड कम्स डाउन. हाउएवर वी थ्रो द प्रोफेशनल सैटेलाइट्स, तो वो एक ऑर्बिट में चक्कर लगाता रहता है. नाउ सी, वी हैव ऑलरेडी टोल्ड यू दैट अ सैटेलाइट मोशन इज सर्कुलर मोशन. If it is a circular motion, then it is satisfying two conditions. One is that it is having an orbital speed, and another one is the force which is acting on it always perpendicular to the instantaneous velocity. You understand? These are the two conditions you have to always satisfy for a motion to be circular. अगर एक सैटेलाइट सर्कुलर मोशन में है तो ये दोनों ही कंडीशन सेटिस्फाई करता रहता है. It has a velocity and always perpendicular force. अगर इसमें force vanish कर जाए, then you will find that satellite will continue in a straight line motion with this speed. अगर ये force vanish कर जाए, तब इसका path circular नहीं रहेगा. It will continue moving in a straight line. And अगर इसकी velocity खत्म हो जाए, in case the velocity of the satellite becomes zero, then this force continues acting और फिर वो सैटेलाइट ग्राउंड की ओर फॉल कर जाएगा. यू अंडरस्टैंड? बट व्हेन बोथ ऑफ देम आर प्रेजेंट, देन सैटेलाइट ना तो इधर जा पाता है ना इधर, वो टर्न हो जाता है एंड कीप्स टर्निंग बिकॉज ऑल द टाइम फोर्स इज एक्टिंग परपेंडिकुलर टू इट्स इंस्टेंटेनियस वेलोसिटी एंड इट कंटिन्यूज इन सर्कुलर मोशन. नाउ सी व्हाट हैपेंस इन अ क्रैकर रॉकेट. क्रैकर रॉकेट जब आप थ्रो करते हैं तो इट गोज अप एंड टॉप पे जाके इसकी वेलोसिटी जीरो हो जाती है, एंड इन दैट केस इट्स ओनली द ग्रेविटेशनल फोर्स एक्टिंग, सो द क्रैकर रॉकेट कम्स डाउन. बट जब हम प्रोफेशनल सैटेलाइट्स थ्रो करते हैं तो रॉकेट विच इज कैरिंग दैट सैटेलाइट एट ए पर्टिकुलर ऑल्टीट्यूड, इट इज प्रोवाइडिंग सम ऑर्बिटल स्पीड टू दैट सैटेलाइट बिफोर दैट रॉकेट गोज ऑफ. रॉकेट खत्म होने के पहले सैटेलाइट को कुछ ऑर्बिटल स्पीड प्रोवाइड करके ही वापस चलाता है और बर्न हो जाता है. एंड वेन एवर दिस सैटेलाइट इज प्लेस्ड इन एन ऑर्बिट, इट इज नॉट प्लेस्ड विद जीरो स्पीड, रादर विद द ऑर्बिटल स्पीड विच इज कैलकुलेटेड अर्लियर. सो सैटेलाइट, प्रोफेशनल सैटेलाइट जब ऑर्बिट में पहुंचते हैं तो उनके पास ये दोनों कंडीशन सेटिस्फाई हो जाती है, एंड दैट इज वाई इट कीप्स मूविंग इन अ सर्कुलर पाथ. नाउ you are convinced that the satellite whenever it is rotating, it is experiencing a force. इस पे एक force लग रहा होता है, and this force is essentially equal to mg. If m is the mass of the satellite, then force equals to mg is all the time acting here, where g will be the acceleration due to gravity of this place and not the g of the surface. You understand? जब भी ये satellite move कर रहा है, then you have to understand it has now two things. One is the orbital speed and another one is the acceleration of this satellite, and which is equal to g. You understand? This is a very important thing to understand, that satellite जब ये रोटेट कर रहा है तो इसकी एक्सेलरेशन जीरो नहीं है, इसकी एक्सेलरेशन g के इक्वल है. and that is also called free fall. If you try to recapitulate the meaning of free fall from our lecture of motion under gravity, हमने कहा था कि free fall means, free fall implies that acceleration is that due to acceleration due to gravity. Initial speed 0 हो भी सकती है, नहीं भी हो सकती है, but whenever an object is having an acceleration that due to acceleration due to gravity, then it was called a free fall. That is why it is always said that a satellite is always under free fall. कई बार आपको फ्री फॉल में ये लगता है कि ये तो सर्कुलर ऑर्बिट में घूम रहा है, फ्री फॉल कहां है इसका? बिकॉज फ्री फॉल से हमारी इमेजिनेशन ये जाती कि इट शुड कम डाउन. नो, फ्री फॉल मीन्स इट हैज जस्ट द एक्सेलरेशन इक्वल टू एक्सेलरेशन ड्यू टू ग्रेविटी. नाउ आपने ये देख रखा है कि इन केस समथिंग इज फॉलिंग विद एक्सेलरेशन ड्यू टू ग्रेविटी, देन if you are sitting on the falling object itself, falling on the accelerating object itself, आप कह सकते हैं कि सैटेलाइट एक accelerated motion में है because it is in circular motion. And आपने देखा है कि in case you sit down on the rotating body itself, that is rotating frame, तो उस पर एक pseudo force लगता है, and pseudo force यहाँ पे किसी भी object की जो weight है उसको balance कर सकता है, and you can say overall the weight has become zero. That means whenever something is kept inside a satellite, then its net weight will become zero because its acceleration is that equal to acceleration due to gravity. You understand? So weightlessness simply means that it is being caused due to the fact that the object or satellite which is rotating, it is having an acceleration that due to gravity. And any object, for example this classroom, if you are in a position to imagine that suddenly this room starts falling with acceleration due to gravity, then all of us will be feeling weightless, we will be floating, and essentially that kind of situation happens that whenever a person is sitting inside a satellite. You might have seen some pictures in which it is shown that astronauts, they are floating inside the cabin of the satellite. It's all because the satellite itself has the acceleration that due to gravity. It is something like a free fall. You understand? And of course whenever there is a free fall, then there are a lot of biological conditions which will be changing inside our body. First of all, the pressure here is zero. If you see the outside pressure, it's zero because there is no atmosphere. So first of all, you will have to maintain the atmospheric pressure inside the satellite. It should be airtight, and that is the reason that those astronauts are put a special kind of dresses inside which air is pumped, and so that they can maintain an atmospheric pressure, otherwise their body will burst. That is one thing. Other thing is that when those astronauts are subjected to a situation in which gravity is absent, then a lot of biological changes, for example our bone starts becoming weak, the size of our heart increases, the blood flow rate that will be changed, they might experience headache. And in case they have spent certain days in a satellite in the state of weightlessness, then by the time they reach the earth, they require a lot of medical help so that they can again get conditioned to the situation of the earth existing. Understand? Those were the biological aspects, but essentially by this concept weightlessness we mean that any object which is kept in a satellite that feels weightless, because the main reason is the acceleration of the satellite is equal to that due to gravity at that particular point, and a satellite is under free fall. Free fall does not mean it should be falling in a straight line, rather free fall simply means that it has acceleration due to gravity. You understand? Now let us talk about the position of our geostationary satellites and position of the polar satellites. Let us talk about geostationary and polar satellites. With reference to the Earth, Try to see the position of these two satellites. The radius of the Earth is capital R, and capital R is around, you can say, 6400 kilometer. That is the radius of the Earth you are taking. We have already told you that whatever may be the orientation of the circular path of a satellite, the center of the satellite orbit and the center of the Earth must coincide. If you see the situation of polar satellites, they are rotating in an orbit somewhere here. These are the polar satellites you have. I am calling it P. The name for Indian polar satellites are IRS, that is Indian Remote Sensing Satellite, and their altitude, you can see this is very small. They're approximately 750 kilometer, you can say. This is rotating around the Earth at this kind of orientation, around 60 degree from the vertical axis which you see here. This is the orientation of the orbit, and here again you can see whatever orbit they have, the center of that is coinciding with the center of the Earth. P, we mean polar satellites. You see, but if you talk about geostationary satellites, then essentially they are rotating in an equatorial plane. They are having an orbit something like this. This is the orientation of the geostationary. I am calling it by G. G is geostationary. Satellites. The name of that is INSAT, Indian Satellite Series, or this P is Indian Remote Sensing Satellites. Understand? And this orbit is, if you see from the center of the Earth, then it is around 42,000 kilometer, and this is rotating in equatorial plane. Again you can see whatever is the plane of this orbit, that will be coinciding with the center of the Earth. Now you see, any country, in case it is throwing this geostationary or geosynchronous satellite, geosynchronous means it is rotating, it appears to us as if it is rotating along with the Earth, then it is maintaining same time period as that of the rotation of the Earth, and that is why these satellites will always appear stationary with respect to surface of the Earth. You see that all these satellite motion, dish TV, everything which you see, in case we are living in northern hemisphere, then our dish TV will be pointing towards south, because all our dish TV, they are looking at this geostationary satellite. But let us suppose we are living in Australia, the southern hemisphere, then all the antennas, all the dish, they will be pointing towards northern hemisphere, because all these dish antennas, they are looking at that geostationary satellites, and they are essentially placed on equatorial plane. These are the questions we can ask, like what is the location, what is the orientation of these geosynchronous or geostationary satellites. They are essentially moving in a equatorial plane at an altitude of 36,000 kilometer, or you can say from the center of the Earth they are maintaining a distance of 42,000 kilometer. Now any country, if it is throwing its geostationary satellite, will be placed in this orbit only. Understand? There is no other orbit involved for placing their geostationary satellites. And by convention, we cannot keep more than 360 satellites on this orbit, or you can say per degree one satellite is available. Otherwise, what will happen, that the adjacent satellites will start influencing each other, and that is why this orbit is also called parking orbit. You understand? This orbit which you see, this is also called parking orbit. And once your satellite has become dysfunctional, then it is necessary that somehow you remove that satellite from that orbit, then only a new place will be created for new satellite. You understand? Because once they are dysfunctional, they will keep rotating like that, and that is useless unless until you are removing them from that particular orbit. new satellites cannot reach there. These are some of the practical things involved with parking orbit. Things we try to highlight here is that whatever may be these satellites, their orientation may be different, but the center of their circular orbit will be coinciding with the center of the Earth. Larger is their altitude, lesser will be their linear speed, and larger will be their time period of rotation. So these are the two satellites which have practical importance for any country. This INSAT is for India. This is geosynchronous satellite, which is for telecommunication, and these polar satellites are launched just to make the remote sensing possible, taking photographs, etc. Now let us talk about some historical aspects of this chapter of gravitation, and that is with the help of Kepler's laws of planetary motion.